In California, looking at where a woman was in her menstrual cycle affected how attractive she found a man to be, what kind of features she found to be attractive. So when she was ovulating, she was attracted to men with clear signs of testosterone, masculine rugged features. However, if she's menstruating or menopausal, she likes a man to have his mouth duct taped, a spear in his chest, and set him on fire. And no further studies are required. Now, of course, this is just a joke, just to introduce you to the idea of the endocrine system, but there is a lot of truth in this. Because your interest in men, or I guess women, although most of the studies have been done in straight women, changes depending on where you are in your menstrual cycle. So if you are fertile, you are hot to trot. Even if you don't realize logically that you're hot to trot. It's like subconsciously you are, and you tart up without meaning to. That's the day that you just decide you want to feel pretty. That's the day you put on the makeup, you drop the neckline, you raise the skirt line, even without meaning to. So, just be aware, you come to school looking pretty, I'm going to point you out and say that you're ovulating. All right, and men sense it. Men can sense subconsciously that you are fertile, that they're picking up your cues, that maybe you are, just put a little more waggle in your step, and you are possibly, this hasn't been absolutely fully documented, but it is clear, we put out something called pheromones, because we are members of the animal kingdom. So we put out smells that indicate, in the case of women, put out where they are in that menstrual cycle, whether or not they are available.
I read a study once that says that a woman's face actually kind of plumps up and becomes more symmetrical during that time in the month too.
Really?
Yeah, because a symmetrical face
Yes.
is considered more attractive.
Yes.
That whenever men look at a woman, when she's menstruating or when she's ovulating, that they prefer the picture of her when she's ovulating because her face looks more symmetrical. I don't know how true that is, but it's something.
That's it. I hadn't heard that one before. I knew that symmetry, Denzel Washington has an almost perfect symmetrical face. That is the width of the eyes, the width from the eye here, the width here, the side of the nose. All of these are perfectly the same, which is what makes him such an attractive man. Automatically, it's because of that symmetry. And it's true in other animals as well. Scorpion flies prefer their males to have symmetrical wings. So lots of that occurs, but I hadn't heard of that the face actually changed. Well, they did a study with, I read this summer, with lap dancers, looking at the amount of tip that they got. And if they were ovulating, they earned twice the tip as if they were pre-ovulatory, and half the tip if they were post-ovulatory or menstruating. Now, how much of that is due to pheromones and how much of it is due to, she puts more waggle in her butt when she's ovulating? I don't know. But even though this was a joke, there is a lot of truth to it. All right. I combined these 3 chapters, which I explained in Blackboard, because I don't like the way your book does it. Your book says, here's the endocrine organ. That's it. And then later, chapters later, this is chapter 11, chapters 19, 20, 18, that's when it says, oh, by the way, remember that endocrine organ? Here's what the hormone does. All right, I like to say, here's the endocrine organ, here's the hormones it puts out, here's what it does. Here's the next endocrine organ, here are the hormones it puts out, here's what it does, which is why I've combined these. And my lecture is all one huge 240 slides long, but I divided it into the 3 sections to make it easier for you to print out the notes and to keep Roland Newby from having a stroke when you're printing out slides in the library. All right, now we're going to be talking again this very thing, endocrine control of homeostasis. Recalling that we finished the nervous system now, where the nervous system used neurotransmitters. We're now going to talk about hormones instead. Let's see the time So you remember that neurotransmitters, they put out their chemical just across the synapse, which is really small. But even so, this chemical has to find its receptor on the target membrane. So the receptor has to match that chemical. And that target cell would not respond unless it had the receptors for that chemical. Adding vodka to your water bottle? Now we're going to talk about the endocrine system now, where cells are releasing a chemical messenger, though this time we call it hormones, floats through the blood, but the only cells that can respond are the ones that have the receptors. So for example, the parathyroid hormone that I gave you earlier, that's flooding my whole body. But the only cells that have the target receptors are the osteoclasts, the kidney, and the intestines. So the only places, parts of the intestines, are the only places that receive the message from the parathyroid hormone, and therefore will respond. And then this whole thing about polar, nonpolar, all of that's true again. You know, hormones that are polar, which most of them are, because most of them are peptides, they are water soluble. They do not have to be carried with a special protein. Their receptor is on the outside of the cell. The hormones that are nonpolar, steroids, and those that act like steroids, such as thyroid hormone, they have to be carried with a protein carrier through the blood because they're not water soluble. They cross the plasma membrane and their receptor is on the inside of the cell. And so just reminding you of the whole polar nonpolar thing, there is the online lecture that does talk about the classification of hormones. Now it works, okay. And then neurohormones, that's where the neuron puts out a chemical that travels through the blood, and that was epinephrine, was the example we saw there. Okay, we already covered that. Now here is a simple endocrine reflex. Calcium drops, parathyroid cells detect that. Notice that they are the sensor and the integrating center. They put out parathyroid hormone that causes the bone in the kidney to start raising the blood calcium, which turns off the pathway. So that was a very simple one. Here's a complex one. This one is the release of insulin. It has about 3 ways, maybe 4, that insulin is released. All right. The first one is the one you're probably already familiar with, that blood glucose goes up, therefore the pancreas starts putting out insulin. But there are additional controllers as well. When you eat, you stretch your belly. Then the pancreas is instructed to put out insulin via the nervous system. Also, the presence of carbohydrates in the gut cause parts of the small intestine, duodenum and jejunum, to put out hormones that cause the pancreas to release insulin. So because of these multiple ways, you actually get a greater increase in insulin by eating glucose than you do by receiving an IV. Receiving an IV, all that would happen, getting glucose IV, is just the rise in glucose is the only stimulus to put out insulin. But if you eat the same amount of glucose, you get these additional controllers that put out more insulin. Okay. First, let's look at the difference between endocrine and exocrine. You have already covered that in the worksheet that you're turning in today from last week. Those of you who signed up for Remind got mine. Don't forget to turn in your endocrine worksheet today. The difference between exocrine and endocrine. Exocrine glands are epithelial origin. It is epithelial cells that are producing and secreting a product. The product goes into a duct and is delivered via a little tube. And the product does nothing. It does not cause any other cell to respond. So when my salivary glands produce saliva, that's it. The end goal was just to produce saliva. There is no cell in my mouth that's going to respond to the presence of saliva. Sweat, well, you put sweat out on your skin. Well, it doesn't make the skin do anything. The sweat itself was the goal. See, that's different than a hormone. When an endocrine cell puts out a product, that product causes other cells to do something. So the hormone itself causes other things to happen. But in the case of the exocrine glands, that isn't. It's in end stage. Now notice I have the specific type of sweat gland that's called the apocrine. The eccrine sweat glands are the ones that cool you off, the ones that you sweat. The apocrine glands are the ones that are in your armpits and groin, and they put out the pheromones. And pheromones are hormones that cause another organism to do something. So a hormone is a chemical released by one organ that causes another organ to do something. A pheromone is a hormone released by an organism that causes another organism to do something. And the animal kingdom and the plant kingdom are rife with, they're smelly. Let's just put it that way, they're very smelly. That's how they communicate with each other, is through pheromones. Sometimes good, sometimes bad. There's the parasitic wasps, for example, that smell when a plant is being eaten by a caterpillar, and then they go find that caterpillar, lay an egg in it. So some are going to use the pheromones against you. Now the endocrine glands, they are not epithelial tissue. They do not have ducts. And the chemical that they put out, the product they put out, causes another cell to do something. The target cell that's going to do something has to have receptors in order to respond. Many endocrine glands, that's their job. That's their sole job. I am an endocrine gland, that is all I do. But there are many other organs and tissues that have cells that produce hormones. So this is from your book showing discrete endocrine glands, although we know that the pancreas is also an exocrine gland. But from your book, a number of other tissues that respond. So when the heart stretches, right, the heart's job is to squish blood around, but when the heart stretches, it puts out a hormone that causes the kidneys to pee more because the blood volume is too high. So that's an example of, the heart's got another job, but when stretched, it will go ahead and put out hormones. And in case you're wondering, yes, this is on the test. We're going to cover all of these to some degree. Touch on at least all of them. Now, some of them get touched on more, like the kidneys. We talk more about erythropoietin when we get to the cardiovascular system and we start talking about the kidneys. Thymus, thymopoietin is stimulating the lymph nodes to make white blood cells. That's all. Otherwise, we cover all of this. And then we've already done the adrenal medulla. So you've already checked off one.